This video will talk about similarity and congruence. Which figures are congruent and which figures are similar? What is the difference? Congruent figures have congruent corresponding angles and congruent corresponding sides. So these two parallelograms are congruent to each other, and these two triangles are congruent to each other. Congruent figures are exactly the same size and shape. Similar figures have congruent corresponding angles, but not sides, although their corresponding sides are proportional. So these two parallelograms are similar, and these two triangles are similar. Similar figures are the same shape, but not the same size. In the figure below, angle Y is congruent to angle A. What is the length of BZ? The first step is to figure out if the triangles are similar. Are they? You know that one set of corresponding angles is congruent, but you need two in order to use the angle-angle theorem. But if you look closely, you will notice that the intersecting lines at angle Z form vertical angles, which means the angles are congruent. With two sets of corresponding angles congruent, you know that the triangles are similar by the angle-angle theorem. Since corresponding sides in similar triangles are proportional, write a proportion to solve for BZ. Since you only have one length in the smaller triangle, you need to include it and its corresponding side in the proportion. The corresponding side in the big triangle is 9. And now you need to set up the proportion correctly so that corresponding sides and triangle sizes are in line. There are many ways to set up the proportion. Just make sure you keep your groupings correct once you start. Starting with 3/9, you will have the small triangle lengths on the top and the large triangle lengths on the bottom. These are the lengths for the first set of corresponding sides. And now set up the lengths for the second set of corresponding sides, which are BZ and 18. So your second side of the proportion will be BZ over 18. To solve the proportion, cross-multiply to get 9BZ is equal to 3 times 18. Simplify and solve to get BZ is equal to 6. Are these two triangles similar? They are. If a line is drawn parallel to a side of a triangle, then the two triangles are similar. Try the following problem. Find the length of TQ in the diagram below. The first question you need to answer is, are the triangles similar? Since TZ is parallel to XZ, the triangles are similar. Now you can set up your proportion. TY in the smaller triangle corresponds to XY in the larger triangle. So fill in 30 square root of 5 over 40 square root of 5 for your first fraction. On the other side, TQ in the smaller triangle corresponds to XZ in the larger. To solve the problem, cross-multiply. Remember that when you multiply numbers with radicals, find the product of the number in front of the radical and then find the product of the number under the radical and leave it under the radical. Divide both sides by 40 square root of 5. Divide the numbers in front of the radicals by each other and then divide what's under the radical and leave it under the radical. To solve for our missing length, TQ is equal to 18 square root of 3. Do you remember the rule for these triangles? In a right triangle, if an altitude is drawn from the vertex with the right angle to the hypotenuse, then the triangle is divided into 3 similar triangles. Try one last problem. BD is an altitude of right triangle ABC. Find the length of BD. You know the triangles are similar since the altitude of the right triangle is drawn from the right angle to the hypotenuse. Draw two of the triangles side by side so you can use proportions to find BD. Do you have enough information to solve for BD? If you want to use proportions, you will need to match at least two corresponding lengths to find the scale factor. Looking at the triangles, none of the given lengths pertain to corresponding sides. Is there a way to find AC so that you have a corresponding value for AB? How do you find the hypotenuse of a right triangle? You can use the Pythagorean theorem. A squared plus B squared is equal to C squared, where A and B are 12 and 16. Simplify and take the square root of both sides to get that AC is equal to 20. And now you have enough information to write a proportion that will solve for BD. Plug in the values so they are lined up by corresponding sides and triangle size. So 12 over 20 is equal to BD over 16. To solve the proportion, cross-multiply and simplify to get that BD is equal to 9.6. So in review, congruent figures have congruent corresponding angles and congruent corresponding sides, and similar figures have congruent corresponding angles and proportional sides. Best of luck!